Recording is in progress. Hello, y'all. This is Code Platoon. Foxtrot evenings and weekends. It is, what is it, the 16th of January? This is week 2, day 2, module 1, higher order functions in JavaScript only. We're not doing them in Python today, or maybe ever. Reason being, these are really popular in JavaScript. You can do this in Python. There's nothing to stop you. And there are, a few that may exist, but this is really popular in JavaScript. JavaScript developers love their higher order functions. They love for each dot map dot filter dot this dot that dot flip it around dot everything, as many possible things as you can put on a single line. They love it. So this is going to be some of the meat and potatoes of what JavaScript developers choose to use instead of, readable, easy things. Higher order functions in JavaScript. The common ones are for each, map, filter, and reduce. And this is what differentiates it from a, standard function. A higher order function can do either or both of these, one or each, one or both, accepts a function as input, and or returns a function. That's it. That's the craziness. Don't let these crazy names, jumble your brain. If somebody asks you about like what a closure is, just, Google it real fast. It's just a function and a function. It's fine. It's nothing crazy, but we have words for everything. Why would you ever want to do such a strange thing? Besides, wanting to save lines, it turns out this gives us the ability to write more general and reusable code. The goal of any programmer is to be the lazy as possible. This means that you want to both avoid repeating yourself and avoid making silly errors. This is true. This is pretty dry. A lot of times when doing JavaScript, you'll find yourself repeating a lot, especially when you get into front-end development and, producing a UI this way, producing UI this way, doing, recalling information from your back end and displaying it a few different ways. You'll start to find patterns in how you display things, and this is where you'll see a lot of this. We'll be doing some math with it today to kind of explain it, but keep in mind most of these things are not done with math. They're done with a lot of different elements, I would say. UI, generally, we're talking JavaScript, we're almost always talking UI, though some like Node. All right, cool. So you want to take an array of numbers and do something for each of those numbers. Sounds like a loop. We know how to do that. There's an array. You got your for, loop here. Yesterday, y'all learned for of and for in. I would prefer those, but you can do it this way. And if we were to run this, as we would all expect, so iterate, start at 0, as long as it's less than, equal to, whichever you prefer. My array dot length I++ is going to iterate, add 1 each time, run through it. Nothing crazy going on here. If we want to do something within that loop, easy peasy. We're all JavaScript noobs here. We will do it this way. Create a new array, like there, and push in the value of this array, which would be your array in the index. This is iterating the index, by the way, and then multiply it by 2, and that should be for 1, 2, 3, 4. We should have 2, 4, 6, 8. Does that make sense? Any questions there? I can prove it to you. I did pull it up. I may as well do it, huh? Where are we at? Oh, we got a fun little Malazan quote there at the top. I'm obsessed. Oh my goodness, what happened? I chopped it off. All right, cool. 2, 4, 6, 8. Looks good, sounds good. This works. There are some minor issues. Let's say we want to do other things with this same kind of with the same work, but we want to make some adjustments, right? Maybe we want to go a little bit further than this. Maybe we want to iterate by a different number. Maybe we don't want to start at 0. Maybe we want to change the multiplication. We're going to be repeating a lot of this stuff each time. It would take us a whole, another 4 lines, 5 lines to write this. We can do a higher order function where we're going to take a function that pulls in a function, does work, and then returns that, so we can have a reusable, beginner function, or returns a function that we can use for other things. You'll see. We're going to abstract out some of the work. I guess this might help explain it. Fortunately, we can move up one level of abstraction and offload all that manual labor onto something else. We can think about this pattern as, I want to start with a list and then do something for each element in the list. That could be created, translated to this kind of pseudocode looking stuff. So function, iterate and do. It would accept some array and then perform an action. That would be cool. Some array, obvious, whatever array we're looking at, but the action, not so obvious. It's this. But we're going to abstract it out. So what we would do, rather, this action here would be captured here with this separate function that we have to write. This is kind of pseudo. It's not going to actually run, but I'm going to walk with it. So there would be our higher order function that we're building from scratch. This is going to be what I would call a helper function. We're talking like real high level right now, so it doesn't matter. But this is going to be this action that gets plugged into here. And then ideally, when it's all said and done, if it were to run, you would have your function invoked, pull an array, run the print methods function, and ideally, it would iterate through each of them. I'm doing something with element. Yeah, looks good. I mean, we can make this run, but let's jump into stuff that's actually part of JavaScript. And it's for each is the first one. So pretty much what we said this was going to do is what for each already does. Let's try it out. I think I deleted my array that I still need. All right, cool. So my array for each print message. Oh, hey, yeah, we still need this. I got a bad habit of deleting lecture code as I'm going, but I don't like having it all written out the whole way because I end up commenting out the wrong thing. So we're gonna go as we go. Spoiler alert. So we've got my array and a function that we have created. This would be our reusable code here, or at least one-off helper function. Print message, take an element. I'm doing something with element. Now for my array, we can plug in this built-in JavaScript higher order function, dot for each. We don't have to define it anywhere. JavaScript already knows what it is. And we can run that. Let's see what happens. I'm doing something with 1, 2, 3, 4. Looks good. Much like we explained earlier, for each. So in this method, we would define a function, pass it in 2 variables. This is a dot method. This could build. This works right with your array. I forget the terminology a little bit, but if you take any old array and do a dot for each, it knows the first argument is that array, and whatever is in the parentheses is the function it's going to run. So you can do some fancy schmancy stuff with this. Yeah. You'll notice what Jordan just said. A little different. We don't need to pass in the array as a parameter. For each manages all the nitty-gritty details of looping for us. All we have to do is give it a function that takes a parameter. In fact, and I like this, we can make this more explicit if you wanted to. if you wanted to make JavaScript developers mad and say, well, I just wanted to see it. This is saying myArray.forEach, and it's establishing an element and then running print message on that element. But you don't have to do that. JavaScript knows. So this works just fine. I mean, I can prove it to you. It should just print it twice, right? Looks good. Same thing. This is just more explicit. More lines, more characters, which means wrong. What does it return, though? This is kind of fun. New array equals this. This isn't Python. If we were to console.log this new array, what would it do? Undefined. It's not returning anything. It accepts a function. It does work on the function. But what it's done, the function doesn't return anything. This would, basically kind of be like, doing something like this. We're not really giving anything back. We're doing work within it, but returning, it's going to kind of be undefined. There's nothing going on here. We're not returning anything useful. I'll do what I think it is. I'm supposed to, yeah, same thing. Cool. Oh, I didn't call it. I'm gonna call it. It's fine. My VS Code setup between personal laptop and work laptop are very, very different. Just exits doesn't do anything. That's fine. That's not really, doesn't matter. We get way off on the deep end. There, it's undefined. That's what I meant to say. So for each, again, doing work, not returning anything when it's done. That is different than what we'll look at, I believe, is the next, is map. Map is a common word you'll hear throughout your time in coding. Mapping generally takes a list and returns another list. Not always a list, sometimes a dictionary, sometimes a object, sometimes a structure, whatever your language calls it. Maps can do those kind of things. So make it even more concise. So very similar. We need to have a helper function running here. But spoiler alert, map basically does the same thing as for each, except it returns a new array. Earlier, if we wanted to capture that, we need to put it into a new variable called array. Map is going to just return one. So if we wanted to double all of the elements in this list, so write a function, double element should return the element times 2. Easy peasy. Map, we're going to set to an array and then return the log of that array. Looks good. myArray.map returns. Remember, higher order functions sometimes take a function, sometimes return. Map's going to do both. It's accepting a function and it's returning, it's not returning a function, it's returning an array. But yeah, that's it. It's new, brand new Whammadime array. It doesn't destroy your old array. It creates a brand new one. It's not changing anything about this. It's mapping it, taking it, doing something, mapping a new array. Does that make sense to everyone? Any questions there about the difference between for each and map?
I'm still a little bit confused about the return from the for each. So is it always going to return undefined?
It is.
Okay.
Reason being, and I should have slowed down a little bit with that. I got too excited. So much like, let me go back to this. It is a function that's not returning anything. There's a difference between console.log and return, right? We need hello worlds here. So take a step back from it and just look at this function. This is a function called hello world. When it's ran, it will write to the console and return nothing. So if I were to just call it and see what it does on the console, great. It writes hello world from there, but it's not doing anything. I can't it's not returning anything of use. If I were to remove this and just return diddly squat, it wouldn't write to the terminal at all. And if I were to try and console.log that, if I were to try and capture that, it would give me undefined. I would need to return something like some other thing to actually get something back. For each is doing work. It is like doing for each of these things, I will perform this action, but it's not giving you an array back. It's not writing it. It's not saving it anywhere. If you want that, you need to tell your function to do something with that. So here, it is going to run through each of these, but we're not capturing that anywhere. We're either just writing to the console and doing nothing, or we're mutating data that we're writing. We could be like doing each of these for each, go write it somewhere else, go save it over here. We could push it into a new array, just like, you know, this here if we wanted. I'm not even, it's gonna get, we're gonna get wild if we start trying to do something like that, but we would basically have to say, we'd have to capture what it is we want to do. At the top level, for each is just performing an action for each of the elements. That's it. No return, nothing like that. We will see this a lot in JavaScript. Asynchronous functions don't return anything, and that's going to get fun. Does that kind of answer the question? Is that
Yeah, just trying to picture an example. You mentioned for web development earlier. So could one example of wanting to repeat something but not really expecting to store or wanting a return or anything like that, could it be maybe I want to add certain elements to a web page a certain amount of times and I just am trying to find a way to do it with the least amount of code possible, and I don't really plan to like I don't need a return value from that or anything. I just want them to pop up on the page.
yeah, kind of. I think, and we're going to start talking real high level about it. Generally, with something like that, we're probably mapping, because if you want it to be displayed on the web page, you need a final product, right? You need a list of elements, a list of HTML tags, something like that. Either, yeah, I mean, you could probably get away with that with for each, but we're going to have to make it more complex. And where is the example of? I'm not about to. This. So if we wanted to be more significant with it, we could do something like in print message, maybe having the work done here. So instead of just console.logging in print message, we would also be saying, oh my God, my JavaScript is failing me right here. Oh, goodness gracious. something like that, but it'd be captured outside, right? Your helper function would be doing some work and mutating data and writing something somewhere. But at the end, we're still not going to return anything from this for each, because it's like, give me some stuff, tell me what you want me to do. I did it, donezo. I have nothing left. The work is done. I ended my process. If you want something back, we'll use map.
Got it. Thank you.
And we did. It's always going to return the same size as the original. It's taking data, taking elements, doing whatever you want to do to them, and then putting them exactly back where they were. In cases where you don't want it to do that, we can filter. All these things, by the way, if you're asking yourself, can't I just write a function and do it myself? Do I need to know map and for each and filter and reduce? Yeah, you can do that. You don't need to use these higher order functions. They are just conventionally very popular, and we need you to know what they are because people use the heck out of them. So that is the purpose of this of this lecture. You need to have seen these before and have a good idea of what they're doing. Because at the end, spoiler alert, this is not craziness. We're not showing you a weird, wacky example. Like, this is not even that many higher order functions being plugged into something. This is common looking JavaScript. I've seen worse. And it can scramble your brain a little bit when you're going myArray.filter is dot map it double dot reduce. You should be able to read these, get a decent idea of what's going on with them. You should be able to, see this filter and have to say, okay, well, let me go see what is even is. And then, oh, map, let me go see what double is. Reduce, oh, let me go double check that. You should be able to read, find it, all that. So not telling you these things because I expect you to be masters of map for each filter reduce. You need to know what they are because they're very common in JavaScript. Filter handles the case where you want to iterate over an array and return a new array, much like map, but this is going to be containing only elements that pass some kind of test. You will be passing it a Boolean. So instead of a map, which is, take it, spin it around, give it back, filter is going to be testing. So let's take a look. Throw all that out of there. Great. So here's our function, our helper function is even. Real easy, takes an element, element modulo 2 equals 0, modulo saying divided by 2, whatever's left is what you return. It should be 0. If it's even, you divide it by 2, should end up with 0 left over. And then we plug everything in. Return value. So much like the map, we're going to be returning a list. So let's capture that. myArray.filter is even. Plug this in. It should iterate through each of them. And if they're even, add them to this list, which we return. Spoiler alert. Yep, it does just that. And since this is returning something, we probably could just nab the whole darn thing right there. And I bet that works just fine. Does it? Brave, Jordan. Writing JavaScript off cuff. Again, just like the map, this does return something, so we can capture it in a console.log. We can save it to a variable if we want to. We don't have to catch it in a helper function. This function returns something. Filter, very, very helpful. Filter's great when you're running through a bunch of JSON. Reduce, very simple and easy to understand with math. Very above my brain capacity when used for the things it's normally used for, which is reducing long lists of text and HTML tags down into a combined component. You'll see some smart use of reduce if you stay in the JavaScript field. I was scared of this for a long time. With math, it's pretty easy to understand though. The last of the standard higher order functions reduce. It's different from the others because it will only return a single value, and the function you pass to it has 2 or 3 parameters. Let's say you want to get the sum of every element in an array. You could loop it. Real simple. The tricky part here is that we need 2 values, the accumulated value and the current value. You've got one that's continually running, and then you're iterating with the other. You can accomplish this with recursion and with, what's it called? Default parameters. I'm talking out my butt, but you can't do this with recursion. So let's create this function here. Sum. It's going to have the accumulated amount in the current element. Then it's just going to add it up. If we were to recurse, we would call this function again and keep running through that. Here, we're just setting it to the side, easy to work with. I'm going to have to copy paste a lot of stuff back when I'm done. I've just remembered, but that's okay. So there's our sum function. And now for the reduce. Again, it's going to take a list. When we run dot reduce, it's going to return one thing. So for this array, run reduce, which takes 2 arguments. Sum, which requires 2 arguments, is going to be an accumulated value and a current element. Let's run it. 10. That's right, because 1 plus 2 plus 3 plus 4 is 10, right? Yeah, it is. Reduce knows that it's going to be handed a function with at least 2 arguments. It knows to start this one at 0 and do something with the current. So from a web development point of view, if we were going to do something like have an HTML tag and start adding divs to it, adding, a nice little chart of somebody's name, picture, profile, whatever, and we're going through a list of them, reduce would slap that all into one big new thing after, trimming it all down. You could do that. I don't want to talk too much about the weird stuff to do with it, but basically turning a bunch of elements into one element. Doesn't have to just be math. This is oh wait, what's going on here? Oh, it's not gonna like that. Or should it should like that, right? Isn't that running anymore? Why not running anymore? What's going on here, y'all? What did I do? Why isn't that doing what I thought it would? Any guesses? I swear I just did this.